Hey, I'm Robin Thomas of Laminar Flow Systems. What we do is we work on these wings to make them work better. This wing looks pretty much of a muchness throughout, but it isn't. We could actually divide this wing into 3 different sections, and we'll find that this section has half as much drag as this section, and half as much as this section. That sounds like nonsense. They look just the same. But I'm going to show you why it's not so, and how we can fix them. Okay. How we can determine how well a wing will work. Let's get down and look close up here. This is a micrometer designed by NASA. And the purpose is to show if the wing is smooth enough to support laminar flow. As long as it's moving gently like this, it's doing great. This is a great section. That needle is just about stationary as we move down the wing. Here we have a little tiny movement, but this section is perfect. And that's why I tell you, this is the one that's perfect. We want to make them all that way. Now here is just a strip of masking tape. This is what NASA uses to make a wing rough. According to NASA, once this tape is in place, this wing is now no longer smooth, but rough. Now, we don't show much here, but the air, when it hits here, it starts to burble. Once it burbles, it does not straighten out again. So although after here it might be perfectly good, we come back to this point, the air has started to burble and will not come back. Now we should go over to the center section, which is the fuel tank section. One characteristic of Piper wings is the closer you get in towards the middle, the more junk there is in them, the less it works. Now here we start off fine again. We're going fine, we're going fine. Look at what's happening here. Ah, we lost it. We really lost it. And we go up the wing, and we come to another line of rivets, and whammo, we lost it again. These sections only require a divergence of 0.03 of an inch, which is just 3 of these little sections before the air tumbles and becomes turbulent. When it becomes turbulent, the drag increases by 5 to 10 times. And this section will have, altogether, the whole part of the wing we're looking at, from front to back, will have twice the drag due to this small excursion here, which is just, well, maybe 0.15 of an inch, is enough to trip and demolish the effectiveness of this whole wing from here on back. So, this part will have twice the drag that this part has. And we aim to correct that. It's not that hard. It can be done. I'll show you how. I just made a statement I'm going to have to defend. And I'm going to defend it with science, not just say so. First I'm going to go to the very book, which is the Bible of wing sections. Theory of Wing Sections by Abbott and von Doenhoff. This page here represents the Piper wing section. And we have 2 drag graphs here. This is the potential low drag 004, and this is the drag of a rough wing section. Now, this difference, which is 2.5 times the drag between these two, is just obtained with a little piece of tape along the leading edge, just like I showed you on that Piper wing. I'm going to tell you something else. This guy has built world record breaking aeroplanes. He knows what he's talking about. Listen to what he says about laminar flow systems and laminar flow airfoils. Laminar flow airfoils must be made accurately to achieve optimum performance. This does not mean super polished. It means they must be geometrically smooth. There can be no bumps or hollows, as the air will speed up over a bump and then slow down over a hollow as small as 0.04 of an inch. This is what we have to avoid, and I'll show you how we do it. Before we go, there's another graphic I want to show you which describes what I was just saying. Here's an airflow going over a wing similar to Piper's, and here's a little indentation. That little indentation starts to disturb things, and it kind of corrects itself. Another indentation comes. This is just like a fuel tank, by the way, and bang, we've lost it. The air becomes turbulent and the drag has doubled. Here's a piece of wing we used to play around with. It's a typical piece, Piper wing. Actually, it's a fuel tank off a Cherokee Arrow. And we have, in fact, worked on it. This part has been semi-finished. This part is untouched and is the way you're going to find it on your aeroplane. If I run my gauge over here, whoops, there we go. Watch it go. You see those big bounces? They are unacceptable. Now, this, of course, we don't even have to talk about. That's just atrocious, but that's the way the wings are. Here is something approaching a finished surface. Now you see we got a smooth flow across the dial. That's going to keep the air smooth and it's going to fly fast. Then, the equivalent of this rivet row has been covered over, and look at us now. Now we can fly. The tools we use for this are pretty simple and straightforward, and you can make them for yourself. There are only 3 tools. This one, we just put some Bondo here, and we slide it like this, just over the top of the rivets, and we avoid touching any rivet, and then as we get to the end, we just flatten it down, and you got it. That's really simple. This other section, which is an indentation caused by the baffle that's underneath here, we're just going to put some Bondo on here, put this tool in it, bend it to a nice even flow, and then we go across like that. There's a little bridge, and you might have seen it, and that bridge is going to be filled with Bondo. When that is done, you're going to use a piece of sandpaper on a shaped block. It's very important to use a shaped block, because if you don't, you're going to get flat sections, and we can't have flat sections on a wing. You've got to have a constant curvature. Otherwise, the air just trips and will become turbulent. So avoid any flat block. This one is curved to the shape of the wing. Watch it. It's sitting there evenly on the wing. Now, over this Bondo section, we just go backwards and forward, backwards and forward, and so on. And the same over this section. When that's finished, you will have equivalent to these. And your drag on your wing will have gone down to half. First, you prepare your surface by sanding it with 80 grit sandpaper. And you mix your Bondo and put a good dollop down. Then, you get your forming tool. You get the right curve on it, and you slide it across as evenly as you can, and for the whole length of the section you want to travel through. You've got it. You'll notice how we got a thick layer here. It goes gradually down to nothing here, and when we put a mic on this, you're going to find it is dead smooth. Once we've finished this, we're going to work on this section. We've got to let it dry first, and I'll pull off this tape, and we'll be ready to work on it. Okay, now we've got a little Bondo mixed to do this line of rivets. I've put a straight edge down the edge here so that we can have a guide for our tool. I've also taped off the rivets at the back, because if you get Bondo on them, it's hard to get off. So, here we go. Dollop the Bondo in place. There we are. Bondo's down. Now, I move this specially formed tool so it's flat at first, and then up we come to give us the shape we want. We've got to try and clear those rivet heads. And down we come. We're doing nicely so far. A few bubbles, but we get rid of those. Oh, you know what I didn't do? I didn't go over this once with raw Bondo first. Always a good idea to do that first. Then you get a nice surface to work onto. So here we go again. I'm running a little short on Bondo here. I won't make the whole strip in one pass, but another pass would do it. Maybe I can even save what I've got here and do it again. As long as your Bondo hasn't gone off, you've got a little extra time. Hey, that worked. Maybe this will work too. maybe not. Anyway, 2 or 3 passes down the road, you should have it done. And you should smooth this little part out here. There we go. The rest can be done with sandpaper, a little spot filler. I'm going to try and do this one a little bit more here.
So if you make a mistake or you don't quite fill it in, you can come back and do it on the second.
It's better to do it the first time. But since you're not perfect, you can sometimes correct. Sometimes you do more harm than good, but we'll see. There we go. That's basically it. We've got a little ridge here, but this will smooth out. A little spot filler will do the job, and you can see the rivets are all covered. Now let's grab this gauge and see how our first section did. This is barely dry, it hasn't been touched by sandpaper. We're just going to see, did we succeed or did we not? So far, excellent. Look at that. The needle's wiggling, but it is not going anywhere. We got it. That was bang on the very first time. It just needs a little more spot filler now, a little sanding. Now when you sand, one thing is very important. Use a hard, curved thing. Then you can sand away like that. Just take off the little ridges. This is just improving an already correct curve.
And then what would be next?
Get a little spot filler. You just get rid of your spots. Like that, you all done this. A little sanding on that. You're ready to fly. At least to paint and then fly. Isn't that incredible? So quick, so easy, and it's all done. Tank fairing, and you're going to need some of these too, because once you've smoothed the wing, there are areas you cannot smooth, which is the edge of each fuel tank, because the fuel tanks have to be removable. These are removable fairings, and once you put them in place, you can see how neatly that fits. All you need to do is take out every third tank screw and put in countersunk screws which we supply, and this looks after that particular rough spot. There are 4 of these in every kit. There are many other parts as well. We've got aileron gap seals, flap gap seals, flap hinges, fairings. We have wheel fairings and wheel well fairings. Altogether, these parts have been proven to give anywhere from 17 to 24 miles an hour increase in speed. When you get that kind of an increase in speed, you get an incredible increase in fuel economy as well. You're going to get 200 to 300 feet per minute increase in rate of climb, a 20 to 30% better glide rate. In fact, I wouldn't fly a plane without it. These photographs are of my Seneca, which I modified in 1982. They're still serving their owner well today, 15 years later, good as new, and I can tell you they've paid for themselves many times over.
Why do you do what you do, and where has it taken you?
Aerodynamics are my passion. I've been an aerodynamicist since I was a kid. I've been designing airplanes, boats, sailboats, all kinds of things that depend on the wind to make them work, since I was a very small boy. I've been doing this for 15 years. A lot of people love what I do.
Okay, what are the benefits?
Everybody gets huge benefits. The major one, economically, is fuel economy. You can save 20 to 30% of your fuel every flight you make. Secondly, glide angle. You can glide a lot further in the event of an engine failure. Thirdly, lower stall speeds. Much, much safer on landing should anything happen. Fourthly, increased control. And there are other ones as well. Cruise speed is not the least of them, and that in turn can save you lots of time.
Now, what do you see for the future with respect to what you've done?
We keep moving ahead. I've got new products, 2 or 3 this year, there'll be more next year. The real future is going to be our new exhaust systems. That is going to be revolutionary.